going to go through today and do some special types of factoring. So there's certain problems that if you recognize they follow a special pattern, then you can do some shortcuts to factor them. So that's what we're going to work on today. Like always with factoring, we know that when we factor, you're doing the multiplication process backwards. So if we understand how to multiply these special cases, it will help us to know how to factor them. So let's start this problem right here. If I have x minus 3 squared and I want to multiply that out, I'm going to go x minus 3 times x minus 3. So let's multiply that out. I go x times x. Just multiplying this all the way out. What happens then is I end up with x squared. These two in the middle, when I combine them, they're the same. So when I combine them, I just double it. Minus 6x plus 9. One thing I want to point out, a common error here is we do sometimes want to just say this is x squared and square the negative 3 plus 9. There is an x squared and a plus 9, but there's also always going to be a middle term when you do one of these perfect squares. So in a minute, we'll do a shortcut on how to do that. But what I want you to do first is pause the video, and I want you to multiply out 5x plus 3. And then come back, and I'll go through it with you, and then we'll talk about how this pattern works. So if I write it out like this, 5x plus 3 times 5x plus 3, distribute 25x squared plus 3x, plus 15x, sorry about that. All right, going 5x times 3, so 15x plus 15x plus 9. So again, I want you to notice we end up with a 25x squared, right? 5x squared and 25x squared. We also end up with 3 squared. We end up with a positive 9. But the key thing here is there's going to be a middle term, right? When I add those together, I end up getting 15 plus 15 is 30x. So there's a shortcut way of multiplying these out, and I'll show you how to do that. First of all, I'm perfectly fine if you do it this way. You can write it out as 5x plus 3 and 5x plus 3 and just distribute. The shortcut is like this, though. You always take the first term and square it. So 5x squared is 25x squared. If you square the last one, 3 squared is 9. If that's a minus, it's still going to be a positive, because if it were a minus 3, it'd be minus 3 times minus 3, still a positive 9. But you got to remember that there's a middle term. The way we find the middle term, this is the important one, is I take the first one, 5x, and I times it by 3x. That's 15x. And then it will always repeat itself. Do you see right here, 15x and 15x? So I take that 15x and times it by 2. And that's how I get the middle term, which is 30x. So that's a shortcut way of multiplying that out. Let's do one more with the shortcut. And then what we're going to focus on mostly here is factoring. So we're going to go the opposite direction. So let's do this one. If I have 3, just did 3. Let's go 2x minus 1 squared. So if you want to use a shortcut to multiply this out, you start by squaring the first term. So if I square 2x, 2x times 2x is 4x squared. And then I square the last one. When I square a minus 1, it's minus 1 times minus 1. Actually ends up being a plus 1. And then you got to find out what is that middle term. So I always times them together. 2x times a minus 1 is a minus 2x. And then you always have to times it by 2. So that would be 4x in the middle there. That's a shortcut way of multiplying that out. Now, if you ever get stuck and forget that, it's not a big deal to go 2x minus 1 times 2x minus 1 and just do the whole distributive property. You will end up with the exact same answer, whichever way you do it. Okay, the whole point behind this is if we come to a problem, like we've been doing problems like this before, the 4p squared plus 12p plus 9. And what we've been doing up until now, right, we look for a common factor. There is not one between all 3 terms. So the next thing we try is, right, we got to figure out what type it is. This is a quadratic trinomial. Not only that, but it's got the 4 out in front. So that means I've got to multiply the first and the last together. 4 times 9 is 36. I've got to find the factors of 36 to add up to be 12. So let's do that. You got 1 and 36, 2 and 18, 3 and 12, 4 and 9. There's a lot of them. 5 doesn't, 6 and 6. Hey, that's the one that adds up to be 12. So I put those in the middle. 4p squared. I replace the 12p with 6p plus 6p. And now I'm going to factor this by grouping. So I'm going to take the first two and put them together. Take the second two and put them together. Take out your common factor. This would be a 2p. So 4 divided by 2, 6 divided by 2. Common factor here is 3. 6 divided by 3, 9 divided by 3. When I'm done, right, I want to make sure that that 2p plus 3 and 2p plus 3 is the same, so I take that out. 2p plus 3. And what's left? Well, when I take that out, I'm left with another 2p plus 3. Well, 2p plus 3 times 2p plus 3 is actually 2p plus 3 squared. So we can get the answer the way we've done it before. But we know how to factor a quadratic trinomial. Here's the thing. If I can recognize that it's one of these perfect squares, then we can go from there to there without doing all that work. So that's what we're focused on today, is recognizing these patterns so that I can makes it faster and easier to do. You don't have to know how to do this, but it's extremely helpful. So let me show you how to do that. Take that problem and rewrite it off to the side, and I'll show you how we can recognize that it's a perfect square. So if I want to avoid all that work, I get to here, and if I look at the first term, I recognize that that's a perfect square. What I mean by a perfect square is I can square something to get 4p squared, and that would be 2p. 2p squared is 4p squared. I can also square something to get 9. That would be 3. The last thing I have to check is when I times those together, 2p times 3 is 6p, and then I times that by 2, it has to equal the middle number, which it does. So that checks off. So now I know that it's a perfect square. I know that it's one of these things down here. So all I have to do now is put a square out there. I put the 2p first, I put the 3 second, and then whatever sign is right there goes in the middle. So it's going to be 2p plus 3 squared. So if you just compare the work, right? This way, if you can recognize that it's a perfect square, this is great. It saves you a lot of work, a lot of time. We're going to go through and practice this a couple of times. I'm going to skip that one. So let's do this one right here. I have 4b squared minus 20b plus 25. Okay, so I want to write this in its factored form. So if I were doing it our old way, I would times the 4 and the 25 together. Anyway, we could go through that whole process. But let's see if the shortcut works. So 4b squared I can write as being 2b squared. 25 I can write as being 5 squared. Now times those together. 2b times 5 is 10b, and times it by 2, it equals 20. So that checks off. It is a perfect square. All I have to do now, I know it's a perfect square. There's a minus. I put the 2b here and the 5 here. I got the minus because of that. That's what tells you that it's a minus down there. And I'm done. That's all I have to do. That's a lot easier than going through that other grouping method. You'd get the same answer, but it just saves you a whole lot of time. I want you guys to try this one right here. So pause the video. See if it's a perfect square or not. If it is a perfect square, then I want you to factor it. It looks like a perfect square, right? I would square 3r to get 9r squared. I would square 4 to get 16. When I times them together, 3r times 4 is 12r. Times it by 2, that equals 24. So we've just verified that it's a perfect square. Don't forget to check that middle term. On your assignment, you're going to have one problem that looks like a perfect square, but when you go to factor it, the middle one doesn't come out to be right, and so you have to do it the old way we did quadratic trinomial. So you've got to make sure you check that middle term. Okay, now that I know that, though, the rest is easy. I know it's a perfect square. The 3r goes here, the 4 goes here, and there's a plus. Okay, and we're finished. So it's such a great time saver. Saves us lots of time and effort. We don't have to go through all that. Hey, let's do this last one. Do one more on your own. These are a little bit tricky, so try this last one on your own. And then, so pause it, try it, and then come back. So check your answer. To get 4x squared, you'd square 2x. To get 1, you'd square 1. 2x times 1 is 2x, times 2 is 4x. So it checks off. We know it's a perfect square then. 2x, 1, there's a plus. So we put a plus in between, and I'm done. That's all there is to it. Okay, so perfect squares. That's the first special case. There is a second one. So to understand that, I'm going to do this multiplication problem. and then we'll do some factoring afterwards. Again, it's always easier to understand the factoring if we understand the multiplication. So let's multiply this out. We go 2x times 2x, 4x squared, 2x times 5, 10x, minus 5 times 2x is minus 10x, minus 5 times 5 would be minus 25. So on the last one, these middle terms were the same, so we just doubled it. On this one, they're opposites. 10x minus 10x is 0. Those just cancel out, which leaves me with 4x squared minus 25. Usually when we multiply out two binomials, we end up with 3 terms. This is the one case where you only end up with 2 terms. The reason why, again, is because of those two middle ones canceling out. What we're going to do then is recognize when this can factor to be this. So to do that, this is your formula. I want you to write this off to the side. These type of problems are called the difference of squares. So difference, supposed to be a C there, sorry, of squares. So when you go to do difference of squares, if you have something squared minus something squared, if it fits that pattern, to factor it, all you do is take that, the first thing, A, and the second thing being squared, the B. And what has to happen, look back over here, to only have the 2 terms, to make those two middle ones cancel, they have to have opposite signs. So all you do is put a minus and a plus, and you're done. There's your factored form. It doesn't matter if you put the plus first, minus second, or the minus first, plus second. You'll be the same thing. Okay, so make sure you have this written in your notes. If you need to pause it for a minute. Make sure you have that written down. And then we'll go through and practice with this second type of problem. So if I have x squared minus 9, the way I recognize that it's one of these difference of squares, first of all, it only has 2 terms. Second of all, it has a minus. It has to have a minus. Doesn't work with a plus. The third thing is, can I write x squared as being something squared? Sure, right? X square x to get x squared. Can I write 9 as being something squared? Absolutely, right? It's 3 squared. If that's the case, then it's automatically a difference of squares. So the 3 things, it has to have 2 terms, it has to have a minus in between, and you have to be able to write the first and the last term as perfect squares. As long as it fits that pattern, the rest is easy. 2 sets of parentheses, x and x, 3 and 3, and in between you just put a plus and a minus, or a minus and a plus. That's it. We're done. We factored it. These are really, for most of us, we do really well with these. These are really easy as long as we can recognize that pattern. 4x squared minus 9. So again, it's got a minus, and it's got 2 terms. So let's check to see if they're perfect squares. So I square 2x to get 4x squared. I square 3 to get 9, and there's a minus in between. Okay, it fits the pattern. So all I do, 2x, 2x, minus 3, plus 3. We got it. We're done. Let's do one more together, then I'll have you try one. So it's got 2 terms. It's got the minus. So the last thing is, are they perfect squares? Sometimes 1 gets confusing, but 1 is a perfect square, right? If I square 1, I get 1. Okay, factor it. 3x, 1, 3x, 1, plus, minus. We got it. You guys try this one right here. So factor that. Pause it and do it, and then I'll go through it with you. So 4m squared, 2m. It's got the minus, 525. Okay, if it's the pattern, all I do is go 2m minus 5, 2m plus 5. That's it. So these are pretty simple, but again, it comes down, the hardest part's recognizing the pattern. It's knowing when to do it. But the key here is the middle term is missing. It's just got the first term and the last term. It's only got 2. And there has to be a minus. If you ever see something like this, 4m squared plus 25, that will not factor. It has to be a minus. It can't be a plus. Other things to be aware of is sometimes you might see something like this. we put it up here. If I have 2x squared minus 32, so it's got two terms, it's got the minus, but you can't square something and get a 2 or get a 32. Well, what happens is sometimes you have a common factor. Don't forget all other stuff we've learned. These two have a common factor. You can take a 2 out. If I took a 2 out, I'd have x squared minus 16. Now look at the inside part. Can I write x squared as being something squared? Sure. Can I write 16 as being something squared? So it factors to be x minus 4, x plus 4, and we got that 2 out in front. Okay, there's our factored form. So make sure you check if there's a common factor, you can check for that too. Okay, as you go through the assignment, most of them are going to either be perfect squares like the first examples we did, or difference of squares like this last set of examples we did. There are a couple on there that I put on there that are not perfect squares. If you get to those, you just have to use those factoring methods that we already know. So don't forget everything else we've done. We know how to factor quadratic trinomials. If it's got 4 terms, we know how to do grouping. We always check for a common factor, so don't forget all that stuff first. All right, thanks, guys.